Unit 30, Geometric Tolerances and Datums. Introduction. Modern day manufacturing processes require precision tolerances to ensure the interchangeability of parts. Mass-produced parts must be held within specified dimensional tolerances to achieve proper function and relationship to mating units. Geometric dimensioning controls the form or position of part features by means of language and symbols. These symbols enable the print reader to interpret dimensions requirements and limit the number of notes on a drawing. The geometric symbol or system of dimensioning is widely accepted practice in industry. This unit describes the key elements to apply the geometric dimensioning. So, terminology, allowance, the intentional difference in size between mating parts. Basic dimension, the exact theoretical dimension used to locate a picture or define a true profile. You got nominal size, the stated design size of the object, which may or may not be the actual size. Feature, the specific portion of an object to which dimensions and tolerances are applied. A feature may include one or more surfaces, holes, slots, threads, and so on. Limits of size, the applicable maximum and minimal size of a feature. Form tolerance, the amount of permissible surface variation from the basic or perfect form. Positional tolerance, the amount of permissible dimension variation from basic to or perfect location. True position, the term used to describe the perfect location of a point, line, or surface. Datum, point, lines, planes, cylinders, axes that are assumed to be exact for purposes of reference. Datums are established from an actual features and are used to establish a relationship for other features. Datum axis is the theoretically exact center line of the datum cylinder. Datum cylinder, or the other geometrical form, theoretically exact form profile of an actual datum feature surface. Datum feature is the actual part, surface, or feature used to establish the datum. Datum plane is a theoretically exact plane established by extremities of the actual feature surface. Specified datum is a surface or feature identified with a datum symbol. Datum target identifies the specific point, line, or area of the object. Datum targets are used to establish a datum for manufacturing and inspection purposes. Least material condition is the condition that exists when a part feature contains the minimum amount of material, for example, the maximum diameter of a hole or the minimum diameter of a shaft. So whichever one weighs the least is the way you can think about that. Regardless of feature size, specifies the feature or datum reference applies regardless of where the feature lies in the size tolerance. Then you got maximum material condition, which is the condition that exists where the part feature contains the maximum amount of material, for example, the minimum diameter of a hole or the maximum diameter of a shaft. So whichever weighs the most. Basic dimensions. A basic dimension is a theoretical exact value of size, profile, orientation, or location of a part. The allowable variation in basic dimensions are established by tolerances in feature control frame. A basic dimension is shown on a drawing by enclosed dimension in a box like this. Datums. A datum is established by or relative to the actual feature of a part. They are used as references from which other features are located. The datums may be points, lines, planes, axes, or cylinders. However, they must not be confused with datum features. A datum feature is a real physical part of an object that may have surface variations. A datum plane is an imaginary line that contains or contacts the datum feature on the highest points of variation. Figure 30.2. One or more datum planes may be used to establish positional relationships of the part. These datum planes are identified as primary, secondary, or tertiary. So that would be your datum feature. Primary datum planes are developed by establishing 3 points of contact on the primary datum surface. The contact points may not be in the same line. So primary, secondary, tertiary. So primary are developed by establishing 3 points contact the secondary are established on the secondary datum feature. The secondary plane is perpendicular to the primary. These 2 points of contact are used to establish a secondary. And then your tertiary is perpendicular to both the primary and secondary datum planes. 1 point of contact is used on the tertiary datum plane. You got datum cylinder, a theoretical exact form profile. The datum is formed by contact of the high points of the datum feature. A datum cylinder may be internal or external as a hole or cylindrical sac. You got datum axis. It is a theoretical exact center line of the datum cylinder. And then you got datum target, are used to establish the position of a part in a datum reference frame by identifying datum target points, lines, or areas of the part. Specified datum targets are often applied to parts such as castings, forgings, and other parts having irregular contours. Datum targets ensure repeatability of part location for machining and inspection purposes. A circular area datum target symbol is shown in 30.7. So like this. Alright, datum identification symbol. Datum features must be identified on a drawing with a data symbol. The symbols indicate a datum surface being referenced. The symbol used with a capital letter enclosed in a box. So figure 30.8 like this. A leader line is used to connect a datum frame to a frame feature reference. A small triangle attached to the end of the leader line establishes the connection of the datum feature. The datum symbol may be attached to a surface extension line or directly to the surface being referenced. So extension line directly to it. Geometric characteristic symbols are used in geometric dimensioning to specify tolerances applied to a part feature. The symbol eliminates the need for written notes on a drawing. Tolerances specified may be tolerances of position or form. The symbols used in characteristics they control are shown in figure 30.1. So all these different ones. Straightness, flatness, and all of that. So feature control frame. The method of applying geometric characteristic symbols and tolerances to drawings is the same as the use for datums. Geometric characteristic symbols are enclosed in a frame. The frame may be divided in 2 or more separate parts. The first space within the frame shows the geometric symbol. The second space specifies the tolerances applied to the feature. If the tolerances applies to a diameter, the symbol for diameter precedes the tolerance dimension. Figure 30.1 or 11 shows typical geometric characteristic symbols. So characteristic symbol, tolerances, datum. And then tolerances zone and diameter symbol. So feature control frames may be located on extension or dimension lines applied to the part features. They may also be referenced to leader lines or located adjacent to dimensional notes pertaining to a part feature. So like this. Alright, here would be your assignment. And we'll start this on the next one.